All right, guys, let's go ahead and start. Shouldn't be too long. It looks like it's going to be a lot, but it's not that much. It's because a lot of it is withdrawing and stuff like that. So don't worry, we are going to connect it eventually with antiderivative because that's what you know what that is. But for now, we're just going to talk about the definition, basics of what we've been doing all of last week. So what did we learn last week? We learned that if we do an infinite amount of rectangles, that this expression on the left becomes the expression on the right. So that dx here is like delta x. And this f of ck, that's for the k's rectangle, right, is like f of x. The a is the starting, and the b is the ending, like where you end. And what am I talking about? Like if I have area under the curve, and I have a curve, here's a, and here is b. Start, end. Now when you're doing your integrand, this integral symbol is like beginning, and then as soon as you see the dx, that ends the integrand, the integral. Does that make sense, guys? Yeah. Okay, so no, so all I'm saying is like integral 1 to 5 of 3x dx, that's it. But if you see something like plus 5, then you still keep going, right? So the dx goes at the very end of everything. You know what I mean? So sometimes they're supposed to use parentheses. They're supposed to use parentheses because this 3x plus 5 is your height and that dx is your width. But it's understood, so don't freak out, like, oh my god, I don't see parentheses, that means it's 5 times dx. It's understood that 3x plus 5 is your f of x and dx is dx. Cool? Okay. Correct. If you have 3x dx and then plus 5, that 5 is not part of the integrand. Now on the AP exam, we're not teaching to the AP exam, of course. We want to know the content. On the AP exam, if you do this error, let's say the function is 3x plus 5 and you forget your dx, sometimes, not always, sometimes they let it go because technically you don't have anything to sum. Like, what are you summing? There's not a Riemann sum. Does that make sense? It's always width times height, width times height, width times height. So you gotta have that dx. Now sometimes they let it go, sometimes they don't. It just depends. So if I were you, just do it right, the correct way. Does that make sense, guys? Okay. So there it is. And now let's talk about our scenarios. So scenario one is like this formula, this example there. All area above the x-axis. So I'm just going to make something up. All area above the x-axis. I'm going to call this A. I'm going to call this B. And I'm going to say that all this area is equal to, what's a nice number, 20? So you would write area under the curve from A to B. You start and you stop. The lower one is start. The upper one is stop. Of this function, I got to call it something, right? F of x, and then close it with a dx, is equal to 20. That's it. Nothing crazy. How do we feel? So that's scenario one, and that's it. It really is that simple. All right, let's do another one. Say it again. The N? The B. Yeah, upper limit of the integral sign. Now, sometimes we count backwards, but we'll talk about that in a little bit. We'll talk about that today. Scenario 2. You have some area above the x-axis, some area below the x-axis. Relax, guys. It's kind of like net displacement. You'll see. Let's all start. I'm going to draw something like this. I'm going to call this A. I'm going to call this B, and I'm not going in alphabetical order. I'm just going to go C and D. Try this. It's all over the place. I wrote A, C, D, B.
You write C and D and extra letters wherever.
Yeah. You guys ready? All right, I'm going to say that this area here, let's choose nice, pretty numbers. I'm going to say that's 10. I'm going to say, you know what, I'm going to color code it. I'm going to say this part right here is 5. That's the area. And I'm going to say this area here is, let's see, that looks bigger than that guy. So should we call it, okay, 12. So I'm going to write 3 different integrals. Only because I did 3 different colors. So I'm going to try to color code it here for you guys. Integral from A to C of this function, I got to call it something, right? F of x. Of this function, f of x equals 10. You always start at A and you stop at C. So does everyone see how the area between A and C is 10? Okay. The one in blue, so let me write it in blue. I'm going to go integral. I start at C and I end at D. I'm going to call it f of x. Now this, I'm not going to call it 5. I'm below the x-axis. So because I'm below the x-axis, I'm going to call this negative 5. And if you were to do width times height, that f of x technically is some negative number. Does that make sense? Okay. So negative 5, and then that one in green. So from D to B. And I know the alphabet's all over the place, but you remember, we're just going left to right, so just look at your picture. F of x dx is equal to 12. And I'm gonna draw one more, or I'm gonna write one more integral. The integral, I'm gonna start at A, and I'm gonna end at B. What do you think this one is? And it's okay if we're wrong, guys. Yeah. Which is what? 17. In case you're wondering how we got that 17, we did this. 10 minus 5 plus 12. Is everything so far pretty easy? Yeah, nothing crazy. Can we continue? All right, so you're already kind of seeing a property here that you know that you can start adding integrals. And we haven't even started talking about properties, but you already see how it's not going to be that bad. Oh, yeah. All right, here we go. And then finally, all area below the x-axis. So this one, I'm just going to go back to red because I feel like red pops. So I have a curve. And this area, we'll call it 10 again. Here's the x-axis. And this is A, and this is B. So area under the curve from A to B, or I guess above the curve and the x-axis of f of x dx is going to be equal to negative 10. Because we're below the x-axis. Cool? And I probably shouldn't be using the word area, guys. I probably should be using the word signed area, because if you just see the word area, you assume that we're talking about just area, absolute value. So if they were to tell you, so I'm using it wrong, but it comes out very little that you'll be fine. If I were to tell you what's the area between A and B, you're going to say 10. But if I tell you what's the signed area between A and B, you're going to say negative 10. If you just see this integral, if I go, what's the integral between A and B of this function f of x, then you're going to tell me negative 10. Does that make sense, guys? And that's what you're going to do today in Delta. You're going to practice a whole bunch on that. Okay. We already talked about this, but we'll talk about it again. This is called the integral sign, the upper limit. So it's like where you end in your function for the area. This is your start, the A. The function is the integrand. So this is the integrand. This is like your delta x, and it can actually be any letter. Integral of f from A to B. So there it is. And it's a dummy variable, guys. All of these, so look at this right here. So I remember last time telling you, we'll talk about it, so now we're going to talk about it. So if I tell you area under the curve, and I guess, yeah, you know, it's okay if we write it here. A to B of f of x dx. If I tell you that this is 3, then it doesn't matter as long as I use the same limits, A, B, and I can call the x-axis whatever axis I want, f of t dt, that is still going to be 3. It doesn't matter what you call the x-axis. The u-axis, you know, A to B of f of u du, that's still going to be 3. Chavez, why? I don't understand. Because remember when we had a function f of x equals x squared plus 3x, in algebra, we said we don't have to use the letter x to have the same quote-unquote expression. If I put a u in there, u squared plus 3u, isn't that the same expression? Like, the only thing I changed was the letter. So it doesn't matter what number I put in there. I can put happy faces. F of happy faces equals happy faces squared plus 3 times happy faces. It doesn't matter. It's the same expression. Cool or not cool? So that's why this is called a dummy variable. It does not matter what letter you have. They're equivalent. As long as the limits are the same. What's up?
What if we not use K? Because I know K is used.
Oh yeah, I, J, and K. Usually they won't use K. They'll use. We use the letter U a lot for U substitution, and we use the letter S a lot. Yeah, we're not going to use the letter K or I, because those are special. I also stands for current in physics, right? So if they use the letter I for current, in engineering they use the letter J for current. Okay, I'll let you guys get there when you guys get there. All right, properties. I'm looking at these properties. We're going to do them all. Relax. I do not like, look at this author. He puts the lower limit A for all of them, except for number 1. He switches it. I do not like that. But it's okay. It's okay. So let me go ahead and do the number 1 the way I like. So I have area under the curve. So I have something like this. Here's A, here's B, and we're going to say that this area is 10. Cool? So if I go area from A to B of f of x dx, you're going to tell me that that is 10. Yes or no? But if you see me do this integral, and look, notice that I put a B there and not an A. B and an upper limit A. So now that means that I am counting backwards, and if I'm going backwards, then this has to be negative 10. Does that make sense? Don't worry, we'll use a real problem, yeah, you know what, I'm thinking of one right now. So let's do a nice big rectangle. So there's a train, oh wait, okay, down here where it says let's chat about the rules. So let's chat about rule number 1. There's a train that's going 50 miles an hour, and I think I used this example last time, but we're going to use it again. So 50, and this is mph, and this is in hours. Between mile marker 1 or hour 1 and hour 3, I'm going 50 miles an hour. I want to know how many miles did I travel between t equals 1 and t equals 3. Now, of course, this is overkill. You would just do length times width and whatever that is. But if you wanted to use calculus, if you were like, I want to show my teacher that I know calculus, then you would go, well, I want to know the area under this curve. Let's call it f of x or f of t, it doesn't matter. Area under the curve from 1 to 3 of this function. And I know how to find the area under this curve. This is just one large rectangle. So 50, and then you just go upper minus lower, 3 minus 1, always. Upper minus lower. So 50 times 2 is, so I traveled 100 miles. Cool or not cool? Now check it out. If I were to reverse it, integral, if I put a 3 in the bottom and a 1 on the bottom and a 1 on the top, f of x dx, because this is just a rectangle, I can find the area again, real simple. I put 50, but now you always do upper minus lower. So 1 minus 3. Notice that now I have a negative. Do you guys see that? Yeah. So now I'm not trying to make you guys robots, but if the limits change, it's the same number, but they just flip, just put a negative in the front, right off the bat. Cool or not cool? Cool. All right, let's see. What other rules do we got? Oh, number 2. You're going to love number 2. Notice that the upper and lower limits are the same. Why is my output 0? Yeah, you can either say the dx, you haven't changed, or the lower and upper are the same, so have you moved? No, you haven't moved, so that's why it's 0. It's like saying this, integral from 1 to 1 of f of x dx. Well, I haven't changed. By definition, your delta x is 0, but you haven't moved. So that's why it's 0. Cool or not cool? I just got the chills. Cool. It's 0, guys. You haven't moved. Remember, we're just doing definitions, what it means. All right, so we covered that one now. Constant multiple. Okay. Wow, I'm so happy that I chose this example. We can use this example for all of them. If I were to tell you that I have a new function, I don't have to call it g of x. Do they call it g of x? Let me see. No, they just put a number in front. If I were to tell you integral from 1 to 3 and I put a 3 in the front, doesn't all that mean I just do a vertical stretch of f of x? So 50 times 3, so now I'm at 150. Yeah, so all that means is if I were to do a new graph, I would be way up here at 150, and here's still 1, and here's still 3. And look, you can still find that area under the curve. What's 150 times 2? 300. So this is supposed to be 300. Well, can't I just take that 100 and multiply by 3 and still give me 300? Yeah, so that's all it's saying. That you can just take that integral that you had a value already and just multiply it by 3. So you could have just gone 3 times integral 1 to 3 of f of x dx. And we already knew that all this right here that I'm circling, we already knew that that was 100. So you can do it. You can do that. See? That makes sense, guys? But I just went ahead. This was an easy function to multiply by 3 by, because it's just a horizontal line. Your lines are going to be curvy, so it's not going to be as easy. Yeah, but it's just like limit properties. If you have like 3, like you have a constant in front of whatever, you can bring it outside. Just like limits. Let's see, what else we got? So we did that one. Sum and difference. Oh, sorry guys. This one is really not that bad. If you have two functions, as long as the limits are the same, you can break them up. That's all it means. So, do I want to draw 2? No, I don't want to draw 2. It's the same as limit properties. If you have two functions, as long as the limits are the same, you can break them up. But the limits must be the same. So the sum and difference, don't worry, we'll get to it. We'll do a visual. Additivity. We kind of already did this, but I'll show you. Yeah, we can show you real quick with one. So additivity is this. And we'll go in alphabetical order. We're going to call this A. I'm going to call this B. I'm going to call that C. So do you guys agree? And I know I probably should color code it, but I'm not going to. Do you guys agree that the area under the curve, A to B of f of x, and where this one stops, the other one begins, B to C of f of x, that all this right here, notice that I put dx on both, all that is the same as writing one integral from A to C of that function? That's all it means. Where one stops, the other one begins. Cool or not cool, guys? And don't worry, we're going to do an example of all these situations. Are we okay so far? Okay. Draw visuals, because I think you guys are visuals. You guys learn better with visuals. Wherever there's a chance to draw a visual, I'll draw a visual. So let's see if we can do this, guys. Ready? So they tell us, suppose that area under the curve from -3 to 0 of g of t dt equals square root of 2. So all my graphs are going to be not to scale, because I don't know what shape I really have. So I have something here. So this is -3, here's 0, and all this area here is just square root of 2. So there's my visual. We still okay? All right. They want to know letter A, 0 to -3 of g of t. What do you think that area is? Are they counting backwards? Yes, because they're counting backwards, this is going to be negative square root of 2. Do you guys see what we did there? How do we feel? I'm going to letter B. Lower limit is -3, upper limit is 0, so it looks like I have the same situation as up there. G of u du. Does it matter what I call the x-axis? Does it matter what I call the x-axis? It doesn't. What does this spit out? Square root of 2. There you go. That's it. Are we still okay, guys? All right, let's go to letter C. They put a negative in the front. If you want, you can treat that like a -1. So I can rewrite this. -1 in the front. -3 to 0 of g of x dx. Do I know what this is? This part right here. Yes, that's square root of 2. And when I multiply by -1, that's going to be, there you go. Do you guys see what we did there? Okay. Letter D. Relax. You can leave it there if you want, guys, but I always like to, that's just a constant, isn't it? Yeah, so I like to do this. Integral, -3 to 0, and remember, you have a 1 here on the top. So I like to do this, and yeah, they didn't put the square root on the top, that's fine. G of r dr. How do we feel about that? Perfect. What's the integral value? Perfect, so just multiply by square root of 2. Square root of 2 over square root of 2, that is just 1. You actually do not have to simplify, but there it is, 1. For now, yes. Are we okay? We haven't done anything crazy, have we? Oh, that's it. Look at that. That's it for that. All right, let's go with this one. I'm going to draw something. It's not going to be to scale. It's the same thing. We're doing the same thing, but it's getting harder. You guys ready? So I know I have two functions. I have an f of x and I have a g of x. So be aware of that. 1 of 2 is -4, so there's some area under the curve. There might be some above. We do not know because we don't know how it looks. We just know the area, the net area. From 1 to 5, it's 6, and then g of x from 1 to 5 is 8. That's all we know. Okay, let's find the rules. Letter A, 2 to 2 of g of x. What's that? Why? Yeah, they're the same, so you haven't moved. Put in there, haven't moved, or whatever you want to do. Letter B, lower limit is 5, upper limit is 1. They give me g of x. Do I have enough information? What is it? -8. Does everyone see how we got -8? Perfect. Let's go to letter C. They go from 1 to 2 to 3 of f of x. Do I have enough information to answer that? Yes. Here's how it looks. 3 times that. And I know that that integral has a value of what? So 3 times -4 is? There you go. Ooh, I like the next one. Child, I don't know what to do for the next one. We don't have 2 to 5. Okay. Everyone put your pencils down. Just listen. I'm going to draw something not to scale. This is not the way this graph looks. I'm just going to draw a random graph. So I'm going to draw a graph 1. And don't write this down, at least not right now. If you want to write it in a little bit, you can. I'm going to put not to scale. 1 all the way to 5. Now, do you agree? Well, I guess let me tell you what I'm going to do first. So here's the area from 1 to 2. Are we still okay? Do you agree if I find the entire area from 1 to 5, so yeah, and I subtract the area in blue, that I'm going to have this in green? Okay, so listen to what you just told me. If I find the entire area from 1 to 5 of f of x, and I subtract the area in blue, which is the area from 1 to what? 1 to 2 of f of x. That will give me the area from 2 to 5 of f of x. Do you guys agree with that? Okay, you can write that down. Write that down, and then we'll continue. Oh, hey, Miss Guerra. I hope you're doing awesome, Miss. She's going to watch the video as soon as we're done with it. All right. Did they give me the area under the curve from 1 to 5 of this function? What was it? 6 minus, did they give me the area under the curve from 1 to 2? What was it? Was it -4? I don't remember, guys. I can't see it. Yeah. So there it is. 6 minus a -4. What happens there? Cool or not cool? Obviously, this picture is not accurate because it says -4. So between 1 and 2, I should be having more area below than above. That's why I put not to scale. But did that illustration help you figure this out? Okay. And that's what you're doing, guys. All right. Letter E. Do we have enough information to answer that? Let's see. 1 to 5 and 1 to 5. Yeah, we do. We do. What type of information must we have? Well, we got to have 1 to 5 for f of x. And do we have 1 of 5 for g of x? Yes. So let's go ahead. We can break it up. You can go integral 1 of 5 of f of x dx minus integral 1 of 5 of g of x dx. Know that usually you don't break it up. You just answer it, but that's fine. What was integral from 1 of 5 of f of x? I already forgot. Minus, what is it for g of x? So 6 minus 8 is? There it is. Bless you. I think we also have enough, let's see, 1 of 5 f of x and g of x. Yep, we got enough information for letter F, so we just continue. So 4 times, is it 6? Minus 8. I hope I didn't do any mistakes. 4 times 6 is 24 minus 8. There it is, guys. Yay or nay? Okay, let's keep going. Oh yeah, these are the ones that are gonna. I was tempted to put some even and odd questions, like something's even, something's odd, but I didn't because we're not there yet. But there's the one that's gonna have no solutions, a few of them. All right, here we go. Again, same thing. I think this one I might have taken it from UH. Negative 1 of 1 f of x dx is 5. 1 of 4 f of x dx is negative 2. Negative 1 of 1 of h of x dx is 7. Letter A. For lower limit, upper limit 1. What is that? 2. Just getting it from this middle one right here. See? Letter B. Do I have enough to figure that out? Yes. Where this one stops, the other one begins, guys. So this is the same, and I'll write it down here. Integral negative 1 to 1 of f of x dx plus integral 1 to 4 of f of x dx. Where this one stops, this one better begin. Does that make sense, guys? So there it is. I linked them for you so you guys can see. 5 plus negative 2. What is that? 3. We feel okay? All right, let's keep going. Letter C. Do we have enough for that one? Yeah, we do. We do, guys. 2 times, what is it for the f of x? 5 plus 3 times 7. What's that? 10 plus 21? 31. Correct. You can split it up and write it as 2 separate things. All right, we finally reached our first one that I think, yep. Do we have enough information for letter D? No, they didn't tell us anything about even or odd. Well, it can't be odd because then this f of x dx would have been 0. But if they would have told us that f of x is even, maybe we could have done something. They don't tell us anything, not enough info. Oh man. Even means that it's symmetric about the y-axis, and odd means that it's symmetric about the origin. You know what I mean? If they would have told us it was even, then I could have just said, well, between negative 1 and 1, the area was 5. So I can just divide by 2 between 0 and 1 and whatever that, if they would have told us it was even. There's no way this would have been odd, because if it was odd, the areas would have canceled each other out. Does that make sense? So this one would have been 0 if it was odd. Does that make sense to you guys or no? Jarrell, are you okay? Okay, for sure. Tell me what I said. All right, so tell me something about even. So if it was even, I could have just done what? If I wanted the area between 0 and 1. They gave me the area between negative 1 and 1. But if I don't want the area between negative 1 and 1, I just want the area between 0 and 1. I could take the area between negative 1 and 1 and divide by, no, not 0, 2. Because look, this area between negative 1 and 0 is the same as the area between 0 and 1. So if they tell you area between negative 1 and 1 of this function is 5, and it's an even function, only if it's even, then the area between 0 and 1 has to be 2.5. Because it's symmetric about the y-axis. Does that make sense? Now, we're not advanced yet. We're not there yet. But that's what we would have done if they would have told us. But did they tell us that f of x was even? They did not. So not enough info. I think the next 3 are going to be. What about letter E? Nope. We don't know anything that happens outside of negative 1 and 1 for h of x. Not enough. Good job. What about letter F? -1 of 4. That's yes, but not perfect. Not enough info for H. We have it for F, but we don't have it for H. Does that make sense, guys? Okay, let's keep going. So this is, obviously you can tell the formatting of this question. I took this one from Delta, so let's give Delta their credit. So here it is. This is the type of questions you're going to get on Delta. The regions A, B, and C in the figure below are bounded by the graph of the function f and the x-axis. The area of region A is 18, so I'm going to put 18 right here. The area of region B is 14, so I put 14 right there. And the area of region C is 8. 8. What's up?
So would it be negative?
Oh, area, if they just say area is absolute value.
So just keep it at
Yeah, for if they say area. Now, if they say signed area, then you would say -18, -14. What is the value of integral -5 to 8 of f of x dx? Okay, now because they tell me the integral symbol between -5 and 8, so mark it. Between -5 and 8, these two values down here are what? Negative. So -5 and 8, so I'm going to go -18 plus -14 plus 8. Does that make sense, guys? Let's see, -18 and 14, 18, 28, 29, 31, 32, and then so -32 plus 8, 32, 22, 24. -24. And that's what you're doing in Delta today. Now, before we continue, you're not going to do Delta first. You're going to do a Raymond sum activity first. And don't worry, Gerald, I'm going to pick on you in a little bit. Do you guys remember how to find area of shapes? Just random regular shapes. A triangle, a rectangle, a circle, pi r squared, a circle, a semicircle. Okay, a trapezoid. Base 1 plus base 2. Okay. All right, relax. You can always cut a trapezoid into a rectangle and a triangle. So you could always, yeah, or if it's a normal one, right? Because it doesn't have to be normal. So if you don't know the area of a trapezoid, it's okay. You can always just cut it up into a rectangle and a triangle. Cool? So all you're doing next, the first delta is going to be like this, and that one should be pretty fast. The next deltas require geometry, and you just need to know area of shapes. It's the same concept. If you have trouble, ask, and we'll help you out. Cool or not cool? Cool? All right, so now I want to bring up Jirella. Don't worry, guys, we're not doing delta real quick. We're going to bring up Jirella, and she's going to help. Jirella, sorry, miss. I hope you're okay with that. And she's going to help us out with reviewing one of the activities. Don't worry, I'm going to hook you guys up. Do you guys remember how to do Raymonds to integrals and integrals to Raymonds? Oh, look at this. I'm going to pass it out. Yeah, but you're going to finish it like in 5 minutes. You're going to see one for you. And then tomorrow, guys, I think I want to go over some pre-response questions from the AP exam, like real ones, or maybe multiple choice. If you have your 2018 exam, bring it. The 2008 exam. I might give you a new one tomorrow as well. All of these are in RAM, just like we did last week. Jarella, take it away.
Okay, so first we're going to solve for the change in x, which is looking at the interval 3 and 1. Oh. Well, we're solving. Yeah, so we're solving for RAM. So going to number 1, let me just take this. Look at this ending and starting intervals. So we're going to solve for change in x first. So 3 minus 1 over n. This is also in last week's notes, which is equal to 2 over n. You take that, and then you also take this starting interval as well. So you're going to go 1 minus 2j over n, and that's your this x to the j. Oh, it's solving for the change, the start and end, and you're looking for in between that interval.
She's talking about the x of j, I think.
Yeah.
Oh, isn't it plus? Yeah, sorry, my bad. Yeah, my bad. Sorry, I was talking about the change in x. Yes, that's plus, my bad. You'll get minus if this were to be negative. This change in x were negative, then you'd get minus. And then you set that in. You're gonna plug it in for the x. So you're gonna have 4, 1 plus 2j over n plus 2, and then dx, which is 2 over n, but you're gonna have it parentheses.
Of course, you had that sigma notation, but she wasn't able to fit it in.
Yeah, sorry.
Remember, a rectangle is approaching infinity from the first rectangle to the nth rectangle. And in case you're wondering why the formatting looks weird, this is not my activity. I took it from, I think her name is Dixie Ross, she's really cool.
Yeah, that's it.
And then, do you guys remember that from last week?
Yes.
Yeah, so that's all you're doing. So do the matching activity real quick, guys, because I want to make sure that you guys stay fresh with that. And you're probably going to see this throughout the year before we hit you over and over again. You should be able to do this quickly, like in 5 minutes. It should not take more than 10. Let's make sure that you do. Good job. Oh yeah. We got fresh markers. Catch. All right, let me upload this video so Ms. Guerra can view it immediately. I'll put this activity in a little bit on Canvas, Ms. Guerra, and I'll put the notes up in a little bit as well.